Do you know that there exists a chemical process which consumes up to 2% of the global energy consumption, that releases up to 3% of the global CO2 emissions, and that consumes up to 5% of all natural gas that we acquire each year? It is so important that we need it everywhere in the world to grow our crops, and that is so useful that most of the crops worldwide grow an abundance of food due to this process that we need to feed the world population. The process I'm talking about is the Harber-Bosch process and was developed at the beginning of the 20th century in Germany by Fritz Haber and Karl Bosch. It was an undertaking to support the German industry with ammonia and also to support the German war effort in World War I. This process combines nitrogen with hydrogen, and this gas mixture is then heated up through turbopumps. This heated up gas mixture is being sent to a chemical reaction vessel where it is poured under pressure from 150 up to 300 bars and is being brought into contact with a catalyst called alpha iron. Here the gas mixture can react to form ammonia, and the mixture is being cooled down, and through a heat exchanger most of the heat within this process can actually be recycled. The rest of the non-reacted gas mixture goes back into the reactor and is being heated up again, and we can also form our liquid ammonia. Here the entire reaction only has an efficiency of 40 to 60%. However, this is good enough and is quite important to the entire world. But why is that? 85% of all ammonia that is being produced worldwide is used to make fertilizers. This is used for our crops to grow more efficiently and to produce more food to support the growing world population. Furthermore, it's being used to also form polyamide as well as nitric acid as well. The production of ammonia each year has been growing quite drastically as the world population has been increasing as well. Now recently, up to 140 million metric tons of ammonia are being produced every single year, and the tendency is that this amount is only growing. If we now want to replace the hydrogen being used in this process from gray hydrogen to green hydrogen, we can see that we already have a quite big undertaking in front of us, and that we need to concern ourselves with producing more green hydrogen. If you want to know more about chemical process in the future, you can leave a like below, and also if you're interested in other topics, you can leave a comment and suggest something that you might be interested in.